Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study the Hooke's joint concept in the case of various mechanisms, or in the chapter of steering gear mechanisms. So in Hooke's joint, we will study what is the ratio of velocity ratio, and what is the maximum velocity, what is the minimum velocity, maximum angular velocity ratio, minimum angular velocity ratio, and also acceleration concepts. This Hooke's joint concept is that where it will be used. It is used where variable angular velocity and intersection is different. Suppose the input diameter, the angular velocity of the input shaft is entirely different from the angular velocity of the output shaft. So there is a variable angular velocity from input to output. So this is one is the input shaft, and it is output shaft. The angle of inclination of the output shaft is alpha, and this position, this is called I end, this is called I arm, and these are the fork. This AB is forks are AB of the I is connected to the fork of the input shaft, and CD is connected to the fork of the output shaft. So these are the three parts are there in hook joint. Now this hook joint is commonly known as, it is known as the universal joint. So where it will be used? It will be used in the case of automobiles to connect two non-parallel and intersecting shafts. Two non-parallel and intersecting shafts, and also use it to shafts with angular misalignment. Angular misalignment means there is alpha is there is angular variation. Now a common application is that to transmit the power from the gearbox to the rear axle to the differential. So this universal joint is used for transmitting the power from gearbox or from directly driving shaft to driven shaft. Okay, used to transmit power from gearbox, that is from engine, to the rear axle. Rear axle is where the differential is located. So the driving shaft rotates at a uniform angular speed, but whereas the driven shaft rotates at a continuously varying angular speed. So it is not same. The angular speed is varied from driving shaft to driven shaft. Next, there are two shafts as I mentioned here. The shaft 1 and the shaft 2 rotates in a fixed bearing. Shaft 1 and shaft 2 rotates in a fixed bearing. Now a complete revolution, this suppose A is making, AB, capital letters AB makes complete revolution, is a circular. So when at that time the CD moves in elliptical path when you are viewing from the top view. Now there are letters are there, A and B, but it is a portion is the I end is there. So, and one more thing, that each shaft having input shaft having a fork ends, that is AB, and the output shaft has a fork ends C and D. But the four ends of the two forks are connected by a eyepiece or centerpiece. I and this is called centerpiece. This centerpiece can be in a shape of cross, square, or sphere. Okay, but the main principle is that it should have 4 pins or 4 arms. 4 pins should be there in that manner. These are the forks. This is the input shaft and it is output shaft. But these forks are having two ends. There are 2 forks are there. That means how many arms should be there? 4 arms should be there, so that it can be connected. So when input shaft is moving, the output shaft in relation to that it will be. So the torque can be transmitted from driving shaft to, that means from engine shaft to rear axle. And one more important principle is that these four arms, the angle between four arms is 90 degree. Okay. Now there are two things are there here. This is AB. This AB means the fork ends, and it is the CD. When we are viewing from top view, the ends becomes, the letters become, AB becomes small letters A and B, and this CD is top view with perpendicular. So C and D will be coincides at point O. That is called CD letters. And the angle of inclination of the shaft, the angle of inclination, this is the axis of the input shaft, then this axis is the axis of output shaft. The angle between these two is alpha. That is what here it is alpha. Now we can describe more the two horizontal shafts, the axis which are at right angle, at angle alpha. This is the angle alpha, connected by this Hooke's joint. So if the joint is viewed along the axis of the shaft, this is along the axis of the shaft, if the joint is viewed, then what will happen? The fork ends of the shaft will be shaft 1. What is the fork end of a fork end for shaft 1 is A and B. And the fork ends of the shaft 2. The shaft 2 is C and D, CD. Okay. So the axis of the shaft 1, the axis of the shaft 1 is along perpendicular to the plane of the paper at O, and that of the shaft 2 along OA. So when viewed from top, C and D, when viewed from top, this is C and D. When viewed from top, C and D coincides at point O, projections and CD. Whereas this AB, small letters AB remains unchanged. Why AB remains? This is the true shape, the horizontal line, the true shape in top view. But where is the perpendicular line is there like a projection, like a dot. That point is coincide with point O. Okay. Now, as the shaft 1 rotates, the shaft 1 is having two fork ends are A and B, AB. Is rotate, is R, AB, R, okay, fork are rotated in a circle. This AB is the path of A and B, that is a circle. And the fork ends C and D of the shaft 2 will move along the path of an ellipse. Along the path of an ellipse, if viewed along the axis of the shaft 1. If you viewed along the shaft 1, what will happen is the true shape. But whereas the shaft 2, okay, the shaft 2 is an ellipse. Okay, if you view, because the shaft 2, the fork ends are like that. But if you see from side view, or if you see in the top view, what will happen? The CD having a circular, and the shaft 1 having ellipse. So here we are viewing through shaft 1 along the 1. That's why the true shape, the path of AB is a circle, and whereas the CD is ellipse. That is the drawing. Okay, in the drawing it will be visible. Now, if it is making an angle, when it turning some angle alpha, what is the projection? This is the top view, and it is front view. Now, if you project it in top view, capital letters we are showing representing or by capital letters in front view and small letters in top view. So this AB is the axis in top view, small letters AB. When it turns an angle, then theta, or the what happens, this fork end becomes proportionately, it makes theta the same, C and D also moves. When we project it to the top view and it is made inclination is theta, this is A1. And where is the B1? This is the B1 point. But the forkends, okay, the output shaft is that moves in alpha, then what will happen? Yeah, it is having inclination of alpha. Very important is that if it is theta, the CD also moves in the direction theta. Okay. But in order to achieve the true shape of the inclination, what we will do, yes, it is the concepts of engineering drawing concepts. We will project this theta inclination onto the top view. Here in the top view, we will draw a line and we'll project it on the front view. Then it becomes a C1 dash. Okay. So when the shaft 1 rotate through an angle theta, so the forkends assumes the positions of A1, B1. Now the angle moved by the shaft 2 be theta when viewing along the axis of the shaft 1. The forkend C takes the position C1. The forkend becomes C2, C1. However, then what will happen? The true angle, okay, turned by the shaft 2 would be, it is viewed along its own axis. So this is a phi when it projects down and it is the true shape angle. Now, after doing this, what is the tan phi by tan theta? From this, what is the tan phi equal to? EC1 dash by opposite side, adjacent side, that is UO. Tan theta equal to, what is the tan theta from this triangle? Tan theta equal to EC1 by EO. Now, if after cancelling EO, both denominator, then it becomes EC1 dash by EC1. Now, the same letters in the top view, these are related to front view. If you come to the top view, EC1 dash becomes small letters EC1 dash and it becomes EC1 becomes EC1 double dash. Okay, EC1 double dash. Now, EC1 by EC1 double dash. Then if you make it 1 by EC1 double dash by EC1. This EC1 double dash by EC1, EC1 double dash by EC1, that is from this angle, that is what is that opposite adjacent side by hypotenuse, this is the triangle. EC1 double dash by EC1, that is cos alpha, that is 1 by cos alpha. Tan phi by tan theta equal to 1 by cos alpha. Now tan theta equal to, what will happen? Tan phi tan cos alpha. Tan phi cos alpha. This is the important equation. That is the angle turned by the forks theta. That is tan theta equal to cos alpha tan phi. This alpha is angle turned by shaft 2, inclination of the shaft 2, and phi E is the true angle of the fork CD. The forks C and D moving motion. Now this is the equation considered as related to 6th chapter, that is 6.4. Now let us find out from this equation. This is the basic equation. So in order to find out the angular velocity ratio, what is the angular velocity ratio? What to do? The driven shaft angle is theta and driving shaft angle is theta, driven shaft angle is phi. So omega 1 equal to angular velocity of the driving shaft, that is d theta by dt, and angular velocity of the driving shaft equal to d phi by dt. Now differentiate with respect to time of this basic equation, tan theta equal to cos alpha tan phi. Then what will happen with respect to time? Tan theta, that is secant square theta d theta by dt equal to cos alpha is the constant we considered, that is secant square phi d phi by dt. Now d phi by dt by d theta by dt equal to secant square theta by cos alpha secant square phi. What is d phi by dt? This d phi by dt is, that is the angular velocity of driven shaft, and d theta by dt angular velocity of driving shaft, that is omega 2 by omega 1 equal to secant square theta by cos alpha. This cos alpha is the constant. What we are going to do, secant square phi. The secant square phi means 1 by cos square theta. And secant square phi means 1 plus tan square phi. Then what will happen? 1 by cos square theta cos alpha times 1 plus. What is the tan phi equal to? From this equation, tan phi equal to tan theta by cos alpha. Substitute the term in the place of tan phi. Then the equation further simplified, 1 by cos square theta cos alpha times 1 plus tan square theta by cos square alpha. Now this is the angular velocity ratio. The angular velocity ratio means the ratio of the angular velocity of driven shaft to the driving shaft. That means output by input. That further simplification, if we make a further simplification, again tan theta equal to sin theta by cos theta, so that we can further simplify it. That is 1 by cos square theta cos alpha times 1 plus sin square theta. Tan square theta means sin theta by cos theta whole square. That is sin square theta by cos square theta times cos square alpha. Now 1 by further simplification, if you make it LCM, common factor, then cos square theta cos alpha will be cancelled. Okay, then finally cos alpha by cos square theta minus, that is cos alpha, that is 1 minus sin square alpha plus sin square theta. Next further, finally omega 2 by omega 1 equal to cos alpha by 1 minus sin square alpha cos square theta. Here very important, this is the angular velocity ratio of driven shaft to driving shaft in terms of angle of inclination of the output shaft and the angle turned by the driving shaft. Now the equation is that omega 2 by omega 1 equal to omega 2 by omega 1 equal to cos alpha by 1 minus sin square alpha cos square theta. So when it will be the maximum, omega 2 by omega 1 ratio equal, that means the input equal to output. There is no frictional loss. The exact power is transferred when this terms becomes unity or equal to 1. When this term is equal to 1, then the ratio between the angle of inclination to the angle of driving shaft, that is cos alpha by 1 minus sin square alpha cos square theta equal to 1. Then cos alpha equal to 1 minus sin square alpha cos square theta. Then cos square theta equal to 1 minus cos alpha by sin square alpha. This is the relationship. Condition for obtaining maximum velocity ratio. The maximum velocity ratio is equal to 1. Now, further simplifying, 1 minus cos alpha by sin square alpha, that means what we are doing, 1 minus cos alpha by sin square alpha is converted into 1 minus cos square alpha. That is a square minus b square. That means a plus b, 1 plus cos alpha into 1 minus cos alpha. That equal to, what is that equation? That is the equation of cos square theta equal to so 1 minus cos alpha will be cancelled. Then cos square theta equal to 1 by 1 plus cos alpha. Then further simplification, this 1 can be written as sin square theta plus cos square theta. Substitute here. Then cos square theta into, then sin square theta by cos square theta plus 1. This sin square theta by cos square theta means that is a tan square theta. Okay. Then sin square theta plus cos square theta. Here it is cos square theta. Then cos square theta cancel. Then what will happen? It becomes again 1 equal to sin square theta by cos square theta plus 1. by 1 plus cos alpha. This 1 plus cos alpha equal to sin square theta plus sin square theta by cos square, that is tan square theta plus 1. Then finally tan square theta equal to tan square theta equal to cos alpha. Then tan theta equal to plus or minus under square root of cos alpha. This is the equation for the ratio of to obtain from where? Then omega 1 equal to omega 2. This is the condition. Maximum angular velocity ratio can be achieved when tan theta equal to under square root of cos alpha. This is the condition should be there. So the angle turned by driving shaft and the relation between this equation shows the relationship between the angle turned by driving shaft to the angle of inclination of the output shaft or driven shaft. Now we know the equation, this omega 2 by omega 1 equal to cos alpha by 1 minus sin square alpha cos square theta. Very, very important equation in order to obtain the minimum or maximum velocity. Now, if omega 2 by omega 1 ratio is minimum, that means it is less than 1. Then that means this 1 minus sin square alpha cos square theta should be a maximum. Then only this omega 1, omega 2 becomes minimum. When it becomes maximum, then cos square theta should be minimum. That theta should become either 90 degree or 270 degree. When theta equal to 90, then cos theta becomes 0. And theta equal to 270, cos theta also becomes 0. Then omega 2 by omega 1 becomes, this term becomes what? 0. Then it becomes cos alpha. Omega 2 by omega 1 equal to cos alpha when the velocity ratio is minimum. This is the condition. Then if you want velocity ratio is maximum, that means 1 minus sin denominator term should be minimum. The denominator term is minimum when theta equal to 0 or 180. Substitute over here, then what will happen? Omega 2 minus omega 2 by omega 1, when theta equal to 0, then cos theta becomes 1. That is cos alpha by 1 minus sin square alpha. That means omega 2 by omega 1, cos alpha by 1 minus sin square alpha, cos square alpha. One term will be cancelled. Then omega 2 by omega 1 equal to 1 by cos alpha. This is the velocity ratio is maximum condition, 1 by cos alpha. And it is omega 2 by omega 1 equal to cos alpha. It is velocity ratio is minimum, and this is the equation, velocity ratio is maximum. Omega 2 by omega 1 equal to 1 by cos alpha. Omega 2 by omega 1 equal to cos alpha. This omega 2 by omega 1 ratio of angular velocities ratio is cos alpha, that is minimum. 1 by cos alpha is maximum. Now these are the variation of the speeds. Okay. Now the variation in the speed of the driving shaft corresponding to the rotation, this is the theta of the driven shaft, it is mentioned in this figure. Now points E, these are the points mentioned here, corresponds to the angular displacements of the driving shaft when angular velocity of the driven shaft is equal. That is omega 1 equal to omega 2 is the maximum condition. The points minimum and maximum, it is a minimum here and it is maximum on the top, and here maximum on the both sides, correspond to the angular displacements of the driving shafts when angular speeds of the driven shafts are minimum and the maximum respectively. Now graphically we are showing here is the representation. Okay, this diagram is known as polar velocity diagram. So the variation of the angular velocity of the driven shaft can be represented by an ellipse and the driving shaft by circle. Such a diagram is known as polar velocity diagram. Now, what is the maximum variation? It is like a coefficient of fluctuation of speed. Similarly here, maximum variation of the velocity of the driven shaft up to its mean velocity is known as the fluctuation or maximum variation. That is omega 2, difference between omega 2 maximum minus omega 2 minimum by omega mean. What is the omega mean equal to? Omega 1 plus omega 2 by 2. So omega mean of is the driven shaft equal to the angular velocity of the omega 1 of the driving shaft of the both the shafts completes for one revolution in the same period of time. So maximum variation, what is omega 2 maximum? Omega maximum, omega minimum by omega mean. That is. So that is omega 1 by cos alpha for maximum. Minimum means omega 1 cos alpha. That is omega 2 maximum by omega 2 mean. Yes. This is the ratio omega 2 by omega 1 equal to 1 by cos alpha. Omega 2 by omega 1 equal to cos alpha. So omega 1 by cos alpha and omega 1 cos alpha by omega 1. Now this is a variation. Only this is the maximum variation. That is 1 minus cos square alpha by cos alpha. That is tan alpha sin alpha is the maximum variation. So these are the formulae we'll use in order to solve the problems given in the case of Hooke's joint. Finally, if alpha is small, the angle between the axis of the two shafts becomes small. Then sin alpha equal to tan alpha equal to alpha. When alpha angle is very small condition, then sin alpha and tan alpha is both are equal. So that maximum variation takes place when it is alpha square. So what is the mean speed? Omega. The mean speed omega is not equal to, very important here, omega 2 plus maximum plus omega 2 minimum 2, as the variation of speed is not linear throughout the rotation of the driven shaft. Now, this is the equation omega 2 by omega 1 obtained as cos alpha by 1 minus sin square alpha cos square. This is the angular velocity ratio. Now, if we want to find out the angular acceleration of the driven shaft, the angular acceleration, from this equation omega 2 by omega 1, from that we can find out the angular velocity of driven shaft. Now, from this, what is the angular acceleration of the driven shaft? We know that equation. From this equation, if we differentiate with respect to time, then it is obtained as d omega 2 by dt equal to omega 2 equal to omega 1 times cos alpha by 1 minus sin square alpha times cos square theta. Now, d omega 2 by dt equal to omega 1 times d by dt of cos alpha by 1 minus sin square alpha cos square theta. If you apply u by v principle, u by v concept formula, then finally it is obtained acceleration, that is d omega 2 by dt. That acceleration of the driven shaft equal to minus omega 1 square times cos alpha sin square alpha sin 2 theta by 1 minus sin square alpha cos square theta whole square. This is the equation. Now, if you want maximum acceleration, what to do? Differentiate d omega this equation with respect to d theta. Then we can obtain, we can see the maximum condition for maximum acceleration. That is 2 sin square alpha by 2 minus sin square alpha cos 2 theta equal to. From that, we can get it. This is the where the angle where the maximum acceleration of the driven shaft can be observed, can be calculated. This is the equation 2 sin square alpha by 2 minus sin square alpha. So in this session we have studied completely what is Hooke's joint and what is the description of the Hooke's joint and what is the application of the Hooke's joint in automobiles, and angular velocity ratio of the driven shaft and angular acceleration of driven shaft. Completely about Hooke's joint concept. Now, how to use those formulae for solving the problems? Let me see here. We can see here, determine the maximum permissible angle We want maximum permissible angle between the shaft axis of a universal joint. If the driving shaft rotates at 800 rpm, that is the speed of the shaft 1, and the total fluctuation of speed does not exceed 60 rpm, that means maximum variation of the speed, that is the variation of the speed, that equal to 60 rpm. Also find the maximum and the minimum speeds of the driven shaft, that is omega 2 by omega 1, 1 by cos alpha, omega 2 by omega 1 equal to cos alpha. This omega 2 by omega 1 by cos alpha gives the maximum speed, and omega 2 by omega 1 equal to cos alpha. This formula gives minimum speed of the driven shaft. What is the driven shaft? Omega 2 is the driven shaft speed and omega 1 is the driving shaft speed. Driving shaft, and it is driven shaft. Alright, let us see how to solve. This is the equation. N1 equal to 800 rpm, that is the driving shaft speed. Variation 60 rpm, that is what? That is about 60 revolutions per minute. This is 800 revolutions per minute. The maximum variation is omega 2 maximum minus omega 2 minimum by omega mean. That equal to, we know the equation, that is 1 minus cos square alpha by cos alpha. This omega 2 maximum, this term we know, that is 60 rpm. Omega mean we know, that is 800 rpm. Substitute here, then we can know the angle turn, that is alpha. That alpha is 15.6. That is what? Find also the total fluctuation, determine the maximum permissible angle between the shaft axis. The shaft between the maximum permissible angle is alpha. That alpha is we found from this formula, that is the maximum variation. Omega 2 maximum minus omega 2 mean by omega mean. That is omega mean is the driving shaft. We consider here that is 800 revolutions per minute. In that manner, we have to solve the angle. Now, after knowing the angle, if you substitute maximum speed of the driven shaft, omega 2 by omega 1 equal to 1 by cos alpha. Substitute what is omega 1 we know, that is N1. What is cos alpha? Alpha we know, that is 15.6. Then omega 2 can be calculated. Or not only omega 2, you can no need to turn N2 by N1, that equal to 1 by cos alpha. Why? How it comes N2 by N1? Substitute, that is omega 2 equal to 2 pi N by 60. 2 pi N2 by 60. Omega 1 2 pi N1 by 60. 2 pi by 60, 2 pi by 60 will be cancelled. Then N2 by N1 equal to 1 by cos alpha. That formula is transformed into in terms of direct revolutions per minute. That is N2 by N1 equal to 1 by cos alpha. That is, if you substitute N1 and cos alpha, that is 830.6 revolutions per minute, RPM. That is the maximum speed of driven shaft. Next objective is that minimum speed of driven shaft. What is the minimum speed of driven shaft? N2 by N1 equal to cos alpha. Then N2 equal to N1 times cos alpha. N1 we know the value, known value, that is 800 revolutions per minute, and alpha is 15.6 degree. That is N1 cos alpha is 800 times alpha, that is 0.963203. Cos alpha, that is 770.6. Now, after observing these values, if you see what is the maximum, is the maximum value, and it is minimum value. Minimum speed is 770.6 revolutions per minute. At an angle of inclination between the two shafts is 15.6 degree. Okay, that's what the concept of this Hooke's joint, and we solved this model 1, first model problem. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.